So this is another circuit. We have three op-amps in this circuit. And you can see that the supply here is plus 15 volt, minus 15 volt, plus 15, minus 15, and plus 10, minus 10. So the output voltage of this op-amp cannot go beyond plus 10 and minus 10, and plus 15, minus 15, and plus 15 and minus 15. However, the question says find IO in terms of V in. So we need to find an expression for IO in terms of V in. We don't know what is V in, but we want to find whether IO depends on V in or not. If it does, how does it depend upon it? So let us start from the knowns. We know this is at 0 volt. So we have this at 0 volts. We know this is at 0 volts, and we know this should be at 0 volt. This is 0 and this is 5 volts. Op-amp characteristic says this must be at 5 volts. Okay, and what else? We just need to scan and see whether we are missing something or not. Okay, so let us apply. Okay, so we know this is at 5 volt. This is 5 volt. So this is at 5 volt. This is at 5 volts. Now look here. This, we know the voltage across this resistor. 0 here, 5 here. So we know a current would flow this way, and that would be 5 minus 0 over 1. That would be 5 milliampere, 1K. This 5 milliampere current will reach here, but it cannot go here because of ideal op-amp characteristics. All this current would flow here. So we know a 5 milliampere current would flow in this resistor, 3 kilo ohm resistor. And here we have 0 volts. So the voltage across this would be 3 into 5, 15 volts. If this is 0, this would be at the current is flowing this way. So it enters the positive end and the negative end. This voltage across this resistor is 15 volts. And this is positive, which is 0. So this must be at minus 15 volts. So if this this is minus 15 volt, and we rise by 3 volts, we reach minus 12 volts. So we know the voltage across this resistor. This is minus 12 volt. 0 volt is higher potential, this is lower potential. So a current would flow in this direction, and that current is going to be 0 minus minus 12 divided by 10. So a 1.2 milliampere current is going to flow in this direction, and we know a 5 milliampere current is coming from here, and this current 1.2 milliampere current is going from here, and no current can go in here. So all this current 1.2 milliampere current must come from here. So this current is 1.2 milliampere, and we can also find the voltage across this. This end will be positive, this negative, because this is a positive current flowing entering this direction. 4 into 1.2 is 4.8 volts. So 4.8 volt across this means this is 0. This must be 4.8 volts. So we know the voltage across this one. This is 4.8 volts. And this is 5 volts. So a current of 0.2 volts. There is 0.2 volt across this resistor. The higher side is the lower side, and the current here would be 5 minus 4.8, 0.2 divided by 4. 0.2 divided by 4 would be 0.05 milliampere. So this current is 0.05 milliampere, and so IO, if we apply KCL here, we can write outward current 1.2 milliampere plus outward current IO minus input current 0.05 milliampere must be equal to 0. So what is IO? IO is minus 1.2 plus 0.05, or IO is equal to minus 1.15 milliampere. And the important thing is it does not depend on V in. So whatever this voltage is, IO does not depend on it, and we have solved it. Although the circuit looks like a scary one, but actually you see okay, very easily you can apply basic circuit analysis rules, and you can solve any circuit. So this circuit, for example, this is an inverting amplifier. So but this is not at ground, so we cannot truly apply all the concepts we have learned so far. Just by using the ideal op-amp characteristics and the passive sign convention, the Ohm's law, and some basic things, we have been able to solve this and find this. So the answer is I naught is minus 1.15 milliampere.